Okay, we'll start up again. All right, so it's June 3rd. It's just Shashank and I today, and sounds like it's just me with an update, but that's okay. There's kind of a lot that went on this week on my end, so I wanted to catch everybody up on that. Which screen is sharing?
The PowerPoint. Okay,
PowerPoint.
it just got down.
There we go. Great. Okay.
I'm seeing the screen with the
Notes, right?
on. Yeah.
Okay. It's better?
Yeah.
Okay. All right. A couple of interesting things. A lot of the stuff is pretty small, but a couple of big pieces. One is I've been in communication with some of the folks at Esri that Aileen Buckley had put me in contact with. I've been pretty interested in getting their like void filling tools a little bit better. So when we work with LiDAR data, a lot of times the cells don't have any values in them, and so we need to do something to fill those, and the options are kind of limited on the ArcGIS side. So I had opened a conversation with them about adding some of the in-painting tools. They haven't been particularly interested in that. They asked me to post some of these things to the ArcGIS ideas page, and so I will do that. But one of the things that I found while poking through that forum was that the D'Errico in-painting routine for filling missing pixels is actually present in the Marine Geospatial Ecology Tools package, which was pretty cool. This was a nice find. I hadn't heard of this package before, but this is the website for it. It's produced out of Duke. It has a bunch of stuff in it. These little toolkits get developed, and they're really great. A lot of times they don't get outside their kind of main track. So I don't do any marine work, so it's not surprising that I hadn't worked with this before. But they do have D'Errico's in-painting routine in it. It looks like it hasn't been updated for Arc Pro, which is a bit of a downside. But that's nice to see. So I've written a version of this for, it was originally written in MATLAB. I wrote a version for it for Python, and so that's present in like the NeilPy toolkit. But it would be nice to have something that was a little bit more integrated tightly with ArcGIS. So I don't know whether I'm going to make use of this or not, since it's not really intended for Arc Pro. But it's nice to know that it's there. I also got a note from somebody on Thingiverse who had said that they'd linked to my models that I made with Earl several years ago. This is, the one that we have in the lab, and yeah, it's pretty neat to see this.
Yeah, I saw a few of these. Like, these look really good. I thought that it was one of us who created the account, but like,
yeah,
people like seeing using it is like really cool.
Yeah, I'm pretty impressed. So this is great. Yeah, one of these things was like 2 million views, I think. So pretty great exposure. I've been working on getting the lab drone, the Lab Hexoon, up and flying. I'll talk a little bit about that later on. But one of the things that I've been wrestling with is like a good way to test out the autonomous flight. I've been resistant to flying in the drone cage for autonomous flights because it's pretty small, and GPS errors can be bigger than you think. And so I was a little bit afraid about flying in there. I'm still not really excited about flying in there. I've made a I've made a mission plan here. I can't remember what the height of the place is. I feel like it's 18 meters, so I might crank the altitude down from 15 to 12 or something, just to give a little bit of extra headroom. Vertical error is often double that of horizontal error, so I don't want to hit the ceiling in there. I don't know whether this is a good idea or not. The bottom line is that we need a place to train, and we need a place to show people how to do autonomous flights. And it's pretty hard to do that off campus. So I don't know. I'll give this a try and we'll see how it goes. But anyway, I made the flight by hand in Mission Planner. This is what it looks like in Notepad. These things just get exported as simple little text files. So it's pretty easy to see the format there, very easy to understand. It's just got a bunch of waypoints and just put in what the waypoints are. You could make this by hand pretty easily.
I had one question. Like,
yep.
When you said like the vertical accuracy is less than the horizontal accuracy always, is there like more chances of the drones being like drifting vertically? Like,
yeah.
Is it like very like how much do you expect it to like drift vertically? Would it like range in meters?
Yeah, so it can be a lot. So vertical error on a GPS with a clear view of the sky is probably going to be in the order of about 3 or 4 meters. It's generally on the order of 1 or 2 on the ground, depending on how things are configured. But one of the complicating factors is often when you launch from the ground, that's where your error is going to be the highest. So once the thing gets in the air, it's generally pretty accurate. But the problem is that your flying height is tuned to your takeoff height, right? So when I say that I want you to fly at an altitude of 15 meters, that's 15 meters from wherever you took off. And your error is at its maximum when it's on the ground, right? Worst view of the sky. Mm-hmm. And so you can get these compounding errors where this is actually how we had our crash in Central America. You know, it thought it was, let's see if I can get this right. It thought it was higher than it really was on takeoff, and then a vertical error brought it down a couple of meters, and so those errors actually stacked, and so we wound up with it flying like 7 or 8 meters below where it thought it was going to fly, where it should have been flying. And so that's why it scraped the trees. So that's I mean, that's a lot. 20.
Yeah, that's a lot.
So you have to be pretty mindful of that vertical and be very conservative with your flight altitudes. So anyway, you know, this is there's not many obstructions. In that case, we were taking off from, you know, a forest, so that was rough. But in this case, it's a much better view of the sky. I wouldn't expect those errors to be as large, but you know, you also don't want to wreck anything. So we'll see how it goes. We'll play it by ear. Okay, so that's what it looks like in Notepad, and this is an actual text paste into the slide in case we want it later, but these are in process. I was working on the CID build stuff, which I'll talk about a little bit more of that in a minute, but one of the, just as a note, I'll move this out of the way. There is a new like number sign in the segmentation toolkit. I don't know how long this has been here because I don't reinstall Cloud Compare that often, so I don't know what version this showed up in. We could do some digging and figure that out, but yeah, you can just like put in the classification number for an extracted set. So as you peel out a tree or a building or a footprint or whatever, or you do like the, you know, separation in you know, like the cloth simulation filter or something like that, you can just assign the classes. So that's great. This is going to be a really easy way to repair classifications in Cloud Compare. We haven't had a great way to do this, so I'm pretty excited about that. I haven't tried it out yet.
So does this still work like branching 1 into 2 and like the second 1 into 2? Does that branching chain work, or like can you just like create a number of classes?
I think you can create a number of classes if I'm interpreting your question correctly. Yeah, so you could have a number of things. I haven't tried it out yet, so I'll be interested to do that and see. I've been working on the rover. I don't think I actually did this about 2 weeks ago, but I don't think I commented on it. And that is that I changed the how the mixes are defined in on the controller. So I've got channel 1 set to the aileron, which is standard. And then channel 3, I actually had this was sort of like misconfigured. And so while I was fixing that, I basically, it occurred to me that we could have channel 3 as a mix between the elevator and the throttle. And what that lets you do, do I have my all right, so what that lets you do when you're driving is, before this side, the left side wasn't used at all, and the right was controlled everything. So forward, back, left, right. But what you can do now with this mix set is, if I set this so that the 0 throttle is at the middle, and if I just move it up, then it stays put, and that means it's going to be continuously driving forward at that speed. And so I don't need to, if you just want to drive it in a straight line for a while, you can just throw the throttle up straight, and it should just go straight. So I found that it's a pretty neat way to control it. It makes it easier to drive. So I'm excited about that. I did a lot of other updates. One of the things that I did was watch these, 3 hours worth of YouTube videos from other people who have made rovers. I think I've had a couple of students do. I know that Cooper did that originally. I hadn't done it, and I just wanted to see what was, if there were any, after having one of these built for a year, if there were any settings or anything that we missed. I don't think we missed anything. The only thing that I thought was interesting was there was a new one with a Lightwear SF45 LiDAR that rocks back and forth and scans. It doesn't build scans in the way that we would want it to, but it is good for obstacle avoidance. So maybe that's something that we will do. I don't know. I set the dip switches on the thing from low is down, high is up, low, high, low, low. I'm missing one. Yeah, I'm not sure why there should be 6 of those there. Anyway, I changed switch 2 from exponential to linear to smooth out the acceleration, and I changed switch 4 from ramping to no ramping. What I was trying to do is to get it to be under a little bit more control when you drive it. One of the things that I found is now it tends to oversteer a little bit. I also updated the firmware to 2.4 at the same time, and I'm not sure which of those things was the thing that caused it to sort of start driving a little bit strangely, but I'll have to figure that out. I spent some time trying to figure out like tuning the throttle and the steering. I think I made a little bit of progress there. I don't know, nothing too great. I don't think. I don't know that it drives any better than it did last week. And then I did a big test on the autonomous driving where I had it like drive out my driveway and then down to the end of the street and then back all autonomously. It's doing a weird thing where it's sort of like halting at a waypoint, and I'm not really sure why. I did notice that the RTK GPS power cut off during the bigger test. I don't know why that happened. I think we're going to need to give the either we're going to need to give the GPS a better power feed, or now I'm thinking maybe we should just switch the thing over to a HERE 3 GPS, which can take an RTK signal anyway. It's like $125. We already have one actually on the drone, so we could test it out for free if we wanted to. But I think we'll probably just move the thing to like take the MLID off of it and use a standard GPS. I don't know. It seems like the easiest way to go to me. Been working on the pictometry data set. This is the, it's 10,000 images for all of Blacksburg and Radford, but I really only care about Blacksburg. So this is 8,000 images. I split it into like images that are facing north and images that are facing east. There are all these oblique photos. Constructed a bunch of GCPs using Google Earth. The Google Earth stuff was better than I thought it was going to be. I should have included a slide on this, but the new Google Earth works well because it gives full float values for the elevation. The old version used to just round it to the nearest meter. So now we've got like full accuracy. It's still limited. It's still not as good as taking an RTK GPS out into the field, but it's a lot faster than doing that, right? Instead of driving out to all of these places and setting a physical unit up, I can just pull these out. And so for initial registration, I still think that this is fine. I'm still using the points that Cam gathered, but I'm then also adding all of these Google ones. So it's coming along. You can still see a lot of areas that have some images that are not registered right. There's still a couple of images that are cameras that are calibrated that shouldn't be. It's slow going because once it's merged like this, then it's 8,000 photos, and Pix4D doesn't really do well with that many. Just the menus are less responsive, and it takes longer to just do recalculations. So I'm going to pick at this another week or two, just in sort of idle cycles, and see how far we can get with it. And then at some point, I'll probably just call it good and move on. Most of the area around campus is reconstructed pretty well. So, I'm not so worried about that. If I can get all of those images for like the main part of Blacksburg, then that's probably fine. This is mostly rural area out here, so I don't really need it. I just like to finish the project off. I asked you to take a look at this, so I expect we'll hear more about this in the future. But this was really interesting. This is OMLOCS, the open locating standard. I know next to nothing about this, but it does sound very promising. It will probably mean that our POSIX system is now outdated, which is a drag. We just spent, I don't know, $2,000 or $3,000 on this system, so it sucks to have it just be old. But that's the way it is. You can't predict how it's going to go. So, but we should look into this OMLOCS standard and see what it is and what it does. Hopefully it's the way forward. Based on your recommendations, actually, I started in on the deep learning tutorials. These were great. So this was just what I needed to get started. So big thank you for finding this palm tree health tutorial. This was perfect. The tutorial had great updated instructions for installing deep learning on Arc 2.9. If you look at the old wiki page, Sam had updated that probably 2 years ago. And you basically had to like manually get all of the right versions installed. And the installation of this new, I forget what it's called, but the package, deep learning framework, just installs, and you don't have to mess around with it. I've actually asked Les to install this in the computer lab in Wallace 101. I'm going to cover I think I'm going to assign this tutorial in analysis and GIS next year. So, I think it's going to be really valuable for people to get some exposure to deep learning. And I'm glad that it's finally easy enough. Even when Sam did it 2 years ago, it was way easier than it was when my last student that messed with it 2 years before that had to do it. So they had already made some good strides, but now they've got it to the point where the installation is easy, and it's basically like a 3-step process to train the model and apply it. So it's so much easier than it used to be. It's ridiculous. So I went through that tutorial. I updated the wiki. I still need to apply it to pixel classification. So the palm tree one like finds palm trees, which is neat. It's it's not as good as you would think. Um,
The results you mean, right?
yeah,
Based on what you train. Yeah. But like it's good to like understand like how to train it in GIS. That's what I found. Even the training like provided by Esri is like okay to understand the concepts, but the results are like not what you would expect.
yeah, yeah. That's totally my impression. Is the people I think deep learning is sort of a magic bullet that it will just work.
That's true too. Whenever
I
we are talking about this, everyone thinks that it would figure everything out.
Yeah, yeah. I got to thinking like, so one of the things that they say early on in the tutorial is like, oh, you'd never be able to do this by hand. It would take, you know, field work would take forever, right? If you like tried to like physically count all these trees,
Hmm.
that would admittedly take forever. But then it was like, oh, you couldn't digitally count them. I'm like, I think you probably could. Like maybe not
Yeah.
for the study area, for the imagery. I mean, it depends on the area that you want to apply it to, but for the area that they gathered,
I kind of thought about this and I calculated like me to take around 8 hours to like count all the trees if I
right?
had to. Yeah.
And it probably takes you 3 hours to run the deep learning package
Yeah.
anyway, maybe two. But yeah, it was a bit of a. I think that's a bit of an unfair compare. Like I think that they're two to their own. And then I was like, I bet you could just do it as like the old way of doing this is you'd take the imagery and you'd count it, and then you'd like make an estimate, right? It's like
Yeah.
statistical sampling techniques, right? Like nobody ever
Like,
suggested that you
yeah.
count every tree. You
Hmm.
like put a couple of
Estimate.
plots and you count trees in those, and then you multiply
And
those out by however big the thing is.
yeah.
I bet you'd get a pretty reasonable number in 10
Yeah,
minutes.
that's true. That's true too. Like the only thing different in the sample set was like there were some areas without palm trees at all.
Yeah, you'd
That
have to
might be,
like pick your sampling areas
yeah.
a little wisely.
Hmm.
Um, but I would be willing to bet that I could come up with something that would be
Better than this.
almost as accurate, probably
Yeah.
equally accurate, and take
Mm.
20
I,
minutes.
I get what you.
So people sometimes forget about like some of the like I don't know, just the old school ways of doing like back of the envelope calculations are often fine. Like
The simplest solution is the best
for
solution
sure,
sometimes.
right? Like, do I need to have a machine learning thing try to count
Yeah.
every tree? Like, probably not. So anyway, um, yeah, it was interesting. Even so, I still think it's worthwhile to learn this stuff. I just people's enthusiasm for deep learning, I think, just needs to be tempered a little bit. Um, I still haven't done this, applied it to pixel classification, so I want to do that. I think it's just using a slightly different tool. As I understand how this probably works, the training is the same, and then it's just whether you're using this detect objects tool or classify pixels tool on the output. So we'll give that a try and sort of see what happens. And then I need to do the point cloud classification. Did you get a chance to try any of these this week?
I like did some more digging on the deep learning stuff, like even the classification stuff in images, and I was just like trying things, but I did not get like a breakthrough in this. I managed to install everything in the Goose computer. That's it in the deep learning side.
Okay, so you've got it installed, but you haven't gone through the Palm tutorial?
I've gone through the Palm tutorial. Like you just said, like classifying stuff is the next. I was also trying on that, and
Okay,
next step would be like LiDAR stuff.
okay,
Yeah.
okay. Great. Yeah, we'll keep working on it together. I'm enjoying having the chance to do this at the same time as you are,
Yeah.
so we can talk
Yeah.
about it, trade notes, and
Yeah.
yeah, I'm learning as much about this as you are. I've had two master students go through on deep learning projects, so I'm familiar with sort of the how it works in principle. Um, and Sam's got that nice ArcPy code for running it. I need to email him or message him and see if he still has those files laying around. We don't need those files, but I think it would be neat to have an example that's sort of like what would it look like to just script it and run it, and maybe I could just pull the stuff out from the palm tree stuff and then be like, and here's how you would run that start to finish as a script, right, rather than like clicking buttons. All righty. I just wanted to mention this as part of that tutorial. It pointed us to Open Aerial Map to download the data. I hadn't seen this before. It seems like a small project so far. There weren't, I guess the statistics are here. 11,000 images, that's nothing. Like, that should be 11 million if that's going to be really useful. But, it's a good start, and hopefully it grows. I think it's a great idea. I hope this takes off. The build stuff. So we're gonna have our first meeting today. Are you gonna be able to join us for that, Shashank?
The meeting.
Oh, did I cut out a little bit? Are you gonna be able to join us for the?
Yeah, I will.
Okay.
I'll be there.
Yeah, that should be a good quick meeting. I want to try to make these meetings snappy. We'll see how it goes. I've got a laptop set up. I had an older, not old, but I've got a previous generation laptop with Windows 11, or I installed Windows 11, Docker, the Percept software. So the LiDAR units themselves look like this. And then it runs its own little web server where you can talk to the LiDAR directly. And then Percept is software that runs in a Docker container. It seems to really need Windows subsystem for Linux 2, which is why I put Windows 11 on there. Anyway, that's all set up. The only thing I'm a little bit stuck on is assigning it a manual IP address. There's something about the net mask that it's asking for in a format that I just don't know. So I'll have to figure that out. But hopefully I'll have that figured out by the end of the day. The idea is to deploy this unit in the CID next week. So you and I can go over there and talk to Kevin, who's the building manager. He comes out of the working group that Tanner and David, whom you'll meet today. So he's not just like a building manager. He's an expert in this kind of stuff. So we're going to mount one of these things on the ceiling, hook it up to an Ethernet cable, bring it back down into the closet, and start gathering data. And I hope it works. We'll find out. Pretty exciting. The second Blickfeld unit shipped. So we're basically trying to decide whether we want to use this system or a competing system. And one of the other guys on the team, David, is evaluating that system. We will be evaluating this system, and then we'll compare notes and sort of see how these things did and try to make a decision about which way we're going to go. We probably are going to need to purchase something like 10 units. Yeah, hopefully we'll be able to make that decision soon, but we need to get the second unit in, and then we need to figure out how to integrate 2 units at the same time, which should be possible in the software. It's designed to do that. I just don't know how to do it until we get one of these units. We're trying to get an estimate for how many units Blickfeld thinks we're going to need. So this is a forward-facing unit. It's got something like I can't remember the angular footprint size. It's like 90 degrees by 30 degrees or something like that. So we're trying to figure out how many of these we're going to need. This is a Matterport scan that I did. So I took the spherical camera out there and tried to capture some of the space. So I got a lot of these photos, which I think is super helpful. So we're going to mount it on the ceiling. I'm going to see if I can find the. Okay, so these bars right here are pipes. And then right here, these are Ethernet ports and power ports right here. So same thing right here. You can see this one. So what we should be able to do is basically clamp it onto this pipe, point it straight down, and then just tap into the power and the Ethernet that's right there. And then I didn't. And then we did a scan with a GeoSlam unit last year. And so this is another rendering of that space. So this is kind of the main space right here. And then there's like a big TV right there. And then we'd be mounting it on these pipes at the top. We're also hoping to monitor this whole hallway right here. And then this hallway in the back. So it's not just this space. It's kind of the whole connected area. So it could be difficult. I mean, we should be able to get a couple of units kind of tracking through this space. I'm hoping not more than 4, 5, 6 in this space, and then another 2 or 4 in this space. So I think maybe 14 would do it. We'll sort of have to see how it goes. And that doesn't do anything for this space either. So this would be another 4 or 5 probably. We had budgeted, I think, for 12. We'll see. I have no idea how many we're going to need to do this job. No, I don't think anybody does. So figure it out once we get the units. All right. So I'm finally getting around to repairing the drone that crashed a few months ago. It really wasn't as bad as I thought. A couple of ESCs needed to be, the wires got sheared and I needed to reconnect those. I may end up just replacing those ESCs. There's no sense in having things that are damaged on there if we don't need to. But they do look fine. So we'll see. I ended up replacing 2 carbon fiber arms, and then the carbon fiber plate at the bottom I'll also replace. It's kind of just dinged up a little bit, so it's not really a big problem. But if we've got the spare, we may as well just use it. Maybe I'll keep the other one just in case. And then hopefully flight test this weekend if I can get it back together today or tomorrow. And I guess that's it. I didn't put any goals down there. I guess I ran out of time. So continue with all of these projects and try to get them back together.
When the arm went in, did it not like hit any part of the drone?
Oh, say again?
When you crashed the drone, you said that one of the arms went inside?
Yeah, it's sort of, how do I explain? 1 second, I'll get a. So it's supposed to mount, there's like a mount for it right here. So pretend it's like that. So it's like this. And it basically impacted like this. And when it impacted, it got pushed out through like that. So it ended up looking like this. So I thought it had broken off, but it actually just got pushed in.
Like, is there like only hollow space inside, like the part where it went in?
Yeah. It's basically hollow. The power distribution is in there, but it's kind of underneath where the arms are. So when the arms slid in there, it just like pulled a couple of wires.
Okay.
So, and it didn't damage the power distribution board. I was worried about that when the wires got plucked off. I thought it might have like pulled off the whole thing, but that didn't happen. So it was a pretty easy repair. We'll test it out carefully and make sure that everything is in good order. I think the worst case scenario is we would have to go back in and replace the power control module, power distribution module, and those 2 ESCs. And all 4 motors I'm going to pull, just because, yeah, I just don't trust them. Like,
when you're repairing the drone, like, isn't there a way to like not have the problem repeat again? Like the hollow space being like filled with something, will that?
so that it doesn't get pushed in. Yeah, that's a good thought. I don't know. In fact, I do need to make sure that I inspect that and make sure that it's not that arm isn't damaged. I'm not so worried about that. I mean, yeah, I don't think we need to worry about that. But I am pretty interested in sort of taking the lessons that I've learned from the Hexoon design and applying it back to the Busy Bee, to get the Busy Bee flying again. We've got some ideas now about better ways to do that. So hopefully we won't need these Hexoons for all that much longer anyway. Hopefully just a year or two and then move on. We'll see. All right. Do you want to give us a quick update for the record, and then we can meet individually and we can talk a little bit more? What have you been working on?
So this week I worked on Google Earth Engine, and I decided that going Python way might be like a little bit more like complex. So I decided to work on JavaScript side of things, and that was not as complicated as I thought, and it makes sense to me right now using JavaScript for like doing things. And I also looked into Planetary Computer, and I think I found a tutorial, like a GitHub collection, like if I like just share my screen for once. So there's this like Planetary Computer examples. I think these might be what I might look forward to in this coming week. So there are like some examples. I've not looked into what it is, but like people have recommended this, so
Okay.
I might be like looking into this. And the data download thing is like working. I'm trying it for a smaller area, and I'll like gradually increase it. And I've also got access to one of the Arc computers in Dr. Escobar's lab, so running like these data sets will not be a problem. And then like I did the update on Goose. Next week I'm going to try compute rasterizer in Goose. So I wanted to ask you, like, is there something peculiar you want me to do with compute rasterizer, or am I just like loading data sets and playing with it?
Oh, yeah, just playing with it.
Okay.
Yep.
I think that's it. So next week goals are like more deep learning stuff, like on LiDAR and things, and then planetary computers might be something I will look at. Yep.
Okay, great. Yeah, it'd be great. I think I'm going to try to do the get to the point cloud, deep learning point cloud classification. So maybe we can talk about that next week.
I also looked onto like OMLux, and I read a bunch of stuff. So is it like what RINEX does for like GPS datasets? Are they just trying to like make a standard so that multiple systems can?
I have no idea. I have no idea. That's what I'm hoping to find out from you.
That's what I was like. I got the idea of like OMLux being the new RINEX for indoor datasets.
Cool. That's more than I know. So that's good info.
I like update you on this like more like next week.
Okay. Yeah, that one's pretty key, because that's going to be an indoor mapping technology that we need to be very familiar with. Maybe that's something that I don't know what Addison's interest is going to be, but I know he's interested in the indoor mapping. Maybe that's something that he wants to take on. But I think you should get us part of the way there and figure out, what it is. And, I'm interested in knowing, like, is our POSIX system really going to be obsolete, or is there like a firmware update or a software update that we could do that's going to make it so that it works with?
I like, from what I read, I did not get like the idea that our like device would be useless. Like, so I think they'll still be in use from what I read. I'm not sure about that, but
good. Yeah, that's all the better. I hope that's true. I hope that's true. Yeah. I'm also interested, like, this doesn't have to be something that you get into necessarily as you're looking up the standard, but like all of those parts are really expensive for what they are. So I wonder if there are alternatives out there for indoor positioning, between Wi-Fi and Bluetooth and a number of other techniques. Like, the POSIX system, I think, was a good bet 2 years ago, even a year ago. But but we always need to keep our eye open for what the latest indoor positioning system technology is going to be, because it's just going to kind of show up one day, and we'll have to figure out like whether we need it or can use it. But, it's not it's an important part of what we're doing. It's not a critical part, but it's more critical for you because of your interest in indoor mapping. So yeah, learn what you can.
So shall we move on to our meeting?
Yep, I'll go ahead and stop the recording and we can get into some of the details.